To solve a rational equation given only variables, you basically want to mimic the same process you would do when you have numerical values instead of just all letters. So if we look at our numerical values, our process here is we know we want to figure out what the LCD is. So we identify our LCD as 2 times 3 times y. You might also write it as 6y in this case, but we'll leave it as 2 times 3 times y just to, again, mimic what we're going to do on the left-hand side. So on the left-hand side, same thing, we're going to find our LCD, and it is c times r times y. So the next step on the right-hand side in solving this style of equation, one technique is to multiply both sides by the LCD. So what we'll end up writing is 2 times 3 times y times a half equals 2 times 3 times y times a third plus 1 over y. The result in doing this, and we'll go ahead and write out the steps here, this looks like 2 times 3 times y times 1, but that just leaves us with 2 times 3 times y. And on the right hand side, same deal, 2 times 3 times y times 1 leaves us with 2 times 3 times y times 1 over 3 plus 2 times 3 times y over y. And the result here is that we want to go ahead and simplify what they have in common. And if you don't get factors that simplify, we haven't really truly multiplied by that LCD. So what we're left with is just 3 times y equals 2 times y plus 2 times 3. We'll do the same thing on the left-hand side. So we're going to multiply both sides by CRY times 1 over C, CRY times 1 over R, and I'm leaving out the dots in between the C, the R, and the Y, just because the letters right next to each other generally means multiply. If you want to leave them in, you can, but I'm just going to leave them out right now. And then we'll repeat. So same thing. This becomes CRY over C, CRY over R, plus CRY over Y. Since we multiplied by the LCD, all the fractions should simplify. And we have RY equals CY plus CR. Now let's jump back to the right-hand side here. Let's make it look a little prettier. This is 3 times y is just 3y. 2 times y is just 2y. And 2 times 3 is 6. So on the right-hand side, what we know we want to do to solve for y is we need to get both terms with y on one side. So to do that, we're going to subtract 2y from both sides. So we end up with 1y equals 6. We're going to do the same exact thing on the left-hand side. So we'll subtract this term with the y from both sides, so that you end up with terms with just y on the left-hand side. The only difference is I don't know what CY and RY are, which means I can't actually combine the like terms. When I'm solving this style of equation, I have my like terms. I have 3y and 2y. I can combine them. With these guys, they're unlike terms, so I cannot do that. But we've made the correct step in putting them together on the left-hand side. Now, back to the right, the next thing we would do is we'd want to go ahead and divide both sides by whatever this coefficient is, so that we can end up with just y equals 6. I don't really have this written in such a way that I could divide anything out. I've got two separate terms, but if I could rewrite this so that I actually had y times something, I could divide out by that something. So the technique that we want to use is one we've used plenty of times before, where we recognize that both of our terms have this y in it. which means that I can use my greatest common factoring technique to pull that y out from both those terms, and I'm left with r minus c. Now I've got y times something, just like over here I had y times something, so I'm just going to divide both sides by the something. In this case, it's this factor of r minus c, and I'm left with y equals cr over r minus c. And we've accomplished our goal of solving for y. So when you're working with equations that only have variables in them, remember they proceed the same way as if you were solving an equation with the usual complement of numbers and letters. It's good to do a side-by-side comparison as you're going through and just follow the same steps that you're used to, only adapt them for the situation that the left-hand side calls for.